Hello everyone, very good evening. I hope you all are good. So today in the class we are further going to read current electricity thing. ठीक है? Done है? So let's start with it. How many of you has practiced question? Because in the last class I discussed shortcuts of this circuit thing, right? I gave you so many tricks. We also solved one or two questions, I would say. So how many of you practiced more questions? I couldn't turn on my camera today because there has been a fault in there. So I cannot, sorry, I'm really, from tomorrow it will be functional. ठीक है? चलो. Let me know how many of you are practicing questions. All previous chapters, I mean, electrostat, capacitor, and then current electricity. Nobody? देखो यार, start taking seriously if you really want to crack exams. So you should, take things in a proper way. Sequence follow करना है. You have to follow the concept and then you have to follow doing more number of questions. That is only going to empower you. Otherwise nothing else will help you in the examination hall. That's the only way to feel safe and powerful and strong, right? So you need to have a focus, more focus on question solving. Please do it. Because concept I am getting cleared in the classroom, I'm also letting you do few number of questions, I would say, but you need to practice more than that. I mean, far more than that. So you should be practicing question. हर क्लास में मैं इस चीज को एम्फसाइज करती हूँ बिकॉज इट इज इम्पोर्टेंट. ठीक है. सो कल के क्लास में इन द प्रीवियस क्लास वी लर्न व्हाट वी सिंपली लर्न two things. Circuit ka shortcuts that I won't go through again. But then I discussed about the battery, है ना? So I talked about two things. One was your EMF and another was your what? Potential difference. ठीक है? So what is this difference between EMF and potential difference across the cell? ठीक है? What is this cell? Cell is just battery. Cell is something that has capacity to, that has a stored charge in it and which can give supply current to the circuit when connected to any circuit. ठीक है? So cell will look like this. It is this. Any cell has certain value of internal resistance. So that is why I said it is R. ठीक है? And it is this potential difference across this V plus V minus. ठीक है. सो पॉजिटिव प्लेट का पोटेंशियल मैंने क्या बोला V प्लस एंड नेगेटिव इलेक्ट्रोड हैज अ पोटेंशियल ऑफ V माइनस व्हेन दिस इज ओपन सर्किट. व्हेन दिस इज ओपन सर्किट मैंने कल के क्लास में बताया था. Open circuit, when this is not closed, when no current is flowing through the battery, then potential difference across its end is equal to the EMF of the cell, and that is equal to how much? EMF will be equal to how much? V प्लस माइनस V माइनस, जिसको हम E से भी इंडिकेट करते हैं. ठीक है. बट व्हेन योर सर्किट इज क्लोज्ड, आई मीन व्हेन इट विल लुक समथिंग लाइक दिस. Let's say we are closing it, so current will flow, and in that case potential difference across the cell will be equal to how much? It will be equal to E minus IR. This thing we discussed. So there is difference between EMF and potential difference. This one we get when there is no current flowing through the cell, and this one we get when there is current flowing through the cell. That is your potential difference. Now let's talk about Kirchhoff's law. ठीक है. आज के क्लास में वी आर गोइंग टू फोकस ऑन KCL एंड KVL. These two are very important in order to solve any sort of question circuit. अगर हमारे पास ये अंडरस्टैंडिंग हो, वी कैन मेक कैलकुलेशन पॉसिबल. Not easier, I would say. Possible, I would say. So this is very much integral part of your current electricity. If you're reading current electricity, you know KCL, you should know it, and you should know KVL. ठीक है. So KCL is what? Kirchhoff's current loop law. ठीक है. So basically Kirchhoff's current law. C stands for what? It stands for current. And this is simply your law. ठीक है. V here stands for what? Voltage. So one law is about current flowing in the circuit, and another law is about voltage across any 2 points or in closed loop. ठीक है. We will traverse it slowly. Let's start with KCL. So KCL says what? The algebraic sum of all currents entering and exiting a node must be equal to 0. So if in your circuit there is a node, let's say this is the node, right? This is a node. Why this is node? Because here certain amount of current is coming, or you can say from this point O, three branches are going out, right? So basically here three branches are meeting, and that is why this is a node. Okay. Now let's say from this branch I1 current is coming, from this branch I3 current is coming to the node, and in this branch I2 current is going out from the node. Okay. Then in according to KCL, whatever is current is coming out to the node thing, same amount of current will go out of this point. Okay. So what is the value of current coming out of here? I1 plus I3. And this would be equal to what? Current going out of that point. And that is equal to I2. So this is basically law of conservation of current. Okay. Or you can say, let me write it here. Law of conservation of charge की बात कर सकते हो, या फिर इसका second meaning क्या हुआ? There is no accumulation of charge happening. Accumulation of charge. क्योंकि चार्ज कहीं भी accumulate नहीं कर रहा, कहीं भी रुक नहीं रहा, इसलिए whatever is coming at this point will go out from this point. That is, no charge accumulation is happening at this point. Whatever is coming is going out. If 10 unit is coming, 10 unit is going out. So nothing is remaining here. Nothing is sitting over that not position, right? So nothing is getting accumulated. Done it? This is your KCL. जैसे हमने ऐसे भी सर्किट को डिवाइड किया था. If you have current, if you have, I mean, battery like this, it has internal resistance, and then there is this circuit, then there is this these resistors, and then it is combined like this. How the current will get divided? At this point, current I is coming, right? And at this point, two currents will flow out, I2 and I3. Then we will clearly say that I is equal to I2 plus I3. So this is basically a law that says that whatever current is coming to the point, same amount of current will go out of that point. This is your KCL. Anyone is having doubt in understanding KCL? Then let me know. Yes, anybody? Priya, Ranju, Sanju, Sri Hari, Tejashwini, Tanush, Venu, Lakshmi, Sri, anybody? Karthik, Dhruv, Adi. Anybody? Okay, Karthik, ठीक है. Again, okay. ठीक है. So what I'm trying to tell is, I'm trying to tell that if देखो simple meaning ये है, let's say from here 10 ampere current is coming, ठीक है? So current flowing out of the battery is 10 ampere. At point O, 10 ampere current is coming. Look at the downward circuit, this circuit, ठीक है? So 10 ampere current is coming. Now at this point O, current has two ways to go into. Either it can go this way or it can go this way. So let's say this way I2 current is going and this way I3 current is going. So at point O, if you look at, there is one branch like here, and here current coming is I, then here current going is I2, and here current going is I3. Then KCL says that whatever current is going, whatever current is getting received by the point O, same amount of current O will let go. Okay? So how much current is coming to the O? I. How much current will go from the O? I. So basically how much is going? I2 this side, I3 this side. So total current going out of the point O is I2 plus I3, and total current coming to the point O is I. So according to KCL, this I has to be equal to how much? I2 plus I3. ठीक है? Yes. Am I able to make it clear?
Yes, ma'am.
Okay, okay. चलो आगे बढ़ते हैं. So KVL is very important. Again, here we need to do more of practice. So we will do that. Now, what is the statement? So it states that total sum of all voltage changes in a closed loop circuit is equal to 0. What is the meaning of it? Let's say here there is a resistance R and then there is a battery. It has internal resistance, small r. Battery ka EMF is E, let's say. Now, if I have to write KVL, it says that sum of voltage changes in a closed loop is equal to 0. Let's first take the closed loop. So let's say this is point A, and we have to actually take the changes of voltage from point O to again O. I mean, we have to start traveling from point O along the circuit. Either you go this way or you travel this way. Let's say we are going this way. So we will travel along the circuit. So we will go first, cover this, then cover this arm, then cover this arm, and finally we will come here. So it says that whatever voltage change in a closed loop circuit, that is equal to 0. Maybe you are not able to understand it now. I will make it more clear. Don't worry. So let me first do that for you. चलो यहाँ पे मैंने एक सर्किट बनाया, ठीक है। हमारे पास मैंने सबसे सिंपल सर्किट लिया. दिस कैन बी द सिंपलेस्ट सर्किट. दिस इज इंटरनल रेजिस्टेंस, दिस इज E and this is R. Now I will ask you what is the value of current that you can write, right? What is the value of current here in terms of E, capital R, small r? क्या होगा बताओ? Come on. What is the net R equivalent is what? प्लीज यार चेंज योर नेम. दिस इज रेडमी. बुलाऊंगी कितना बुरा लगता है, सोचो. I'm asking what is the value of current in the circuit that I have drawn just here, in terms of E, small r and capital R. करंट का वैल्यू क्या लिखोगे? Anyone? You need to tell me. I mean, this is the most basic thing that I can ask from current electricity. If I won't get this answer, I will feel low and bad, yeah. I mean, it means I've taught you nothing. Yes. Please, anybody can unmute themselves and let me know. I request. Thanush, current क्या होता है? Please don't do such mistakes, please. KVL का I mean Ohm's law क्या कहता है? V equal to IR. R is what? Resistance. V is what? Potential present in the circuit, right? Yes, Tejashwini. What is the value of R equivalent here in this circuit? Okay, let you should tell me now what is the R equivalent of the circuit. Tell me first this. What is the R equivalent of the circuit? Anybody? Yes, Kiran. Yes, Venu. So what will be the current? R equivalent, if you know, then what will be the current? There is only one battery, right? So current will be battery ka whatever is the EMF divided by R plus R. Whatever is the EMF of the battery, ठीक है? Current will be this much. So now you know the current, ठीक है? करंट को हमने ऐसे लिखा. अब देखो यहाँ पे बताना क्या है? Sum of all voltage changes. अब voltage changes you will be taking across what things? Yes, Mahesh, that's correct. So voltage changes हमें किसके किसके क्रॉस लेना होगा? एज सपोज कर लो मैंने ए पॉइंट से चलना स्टार्ट किया. इट इज टॉकिंग अबाउट क्लोज लूप. वोल्टेज चेंजेस इन ए क्लोज लूप सर्किट इज इक्वल टू 0. सो क्लोज लूप कहने का मतलब इफ यू आर स्टार्टिंग फ्रॉम पॉइंट ए and you start traveling along the circuit, then you have to end your journey at A itself. Then only you are moving in the closed loop, right? So if I start from A and move in this sense, Then first I will encounter capital R, then I will encounter small r, and then I will encounter EMF of the battery. Now, how when we travel across the circuit, what we have to take? We have to take voltage changes. That is, we have to take voltage drop or voltage, simple. We have to talk about voltage across that element. ठीक है? So when you move from A, B to C to D and again to A, you are moving in what sense? A to B, B to C, and C to D, and again to A. You are moving like this. ठीक है? So when you are moving from A to B, there is no circuit element. There is a conducting wire. There is no resistor, no battery, nothing because of which potential will change. So यहाँ तो हमें कुछ लेना नहीं है. When you will move from B to C, there is a change happening in potential. Potential of point B won't be equal to potential at point C. There is a potential change. And how we will write potential change across the resistor? Across resistor, you already know, if current flowing is I, then across it potential will be how much? IR. So this change is positive or negative. तो चलो एक लॉ को हम लिखते हैं, सिंपल है यहाँ पे. इफ यू ट्रैवल, अगर आप ट्रैवल करते हो इन द डायरेक्शन ऑफ करंट, अगर करंट के डायरेक्शन में आप ट्रैवल कर रहे हो तो क्या होगा? देन delta V across R, then potential change across R is taken as what? Is taken as negative. Remember this thing. Potential change will be taken as what? Negative. ठीक है? So अगर यहाँ से अगर मैं लिखूं KVL, तो सबसे पहले मैं A पॉइंट से चली VA, और मुझे पहला एलिमेंट सर्किट का क्या मिलेगा? capital R, that is resistor, and we are moving in the direction of current. So when we move in the direction of current, then delta V across R is taken as negative. So first I will put here negative sign, and then voltage ka value across the element, so that is equal to I into R. So I will put here I into R. Again, I am coming to C and D. There is no circuit element, so nothing to write here. Then when you will move across this from D to A, then first you will encounter this small r. ठीक है? Just give me some second, please. डन है, डन है. ठीक है. सो यहाँ से अगर मैं डी से चलना स्टार्ट करूं, डी से ए की तरफ, पहला एलिमेंट व्हाट यू आर गोइंग टू गेट? यू आर गोइंग टू गेट आर. सो अक्रॉस आर अगेन यू आर मूविंग इन द डायरेक्शन ऑफ करंट, and across R potential drop value will be how much? I into small r. And what sign you are going to take? You are going to take negative sign. Why? Because you are moving in the direction of current. And whenever you move in the direction of current, then across registers, potential drop we will be taking as negative. That is potential change as negative. ठीक है? Negative ले लिया हमने, minus I into small r. Now, what about battery? Battery में हम कैसे लेंगे? So ध्यान से देखो, when I am moving along this direction, it means I am moving from negative terminal to positive potential, positive terminal, right? I am moving from what? Negative to positive. So basically, negative terminal has negative potential, positive terminal has positive potential. So when you are moving from negative to positive potential, potential is increasing or decreasing? मुझे ये बताओ. पोटेंशियल क्या हो रहा है, इंक्रीज हो रहा है या डिक्रीज हो रहा है? व्हेन यू आर मूविंग फ्रॉम नेगेटिव टू पॉजिटिव टर्मिनल, व्हाट इज हैपनिंग टू द पोटेंशियल? किरण, इट इज इंक्रीजिंग, राइट? क्योंकि यू आर मूविंग फ्रॉम लोअर पोटेंशियल टू हायर पोटेंशियल. So basically, you are moving from a lower potential region to higher potential region, and hence you will be writing here positive. So whenever you move from negative terminal to positive terminal, give positive sign. Whenever you move from positive terminal to negative terminal, give negative sign. I will make you understand it more, don't worry. Plus क्या लिखूं यहाँ पे? E, because here the potential is E itself, so we don't need to write anything else. ठीक है? So E here, and finally you have reached where? A. So अब आप equal to sign देना and A. That is how we can potential at A. That is how we can write KVL. This is how we write KVL. ठीक है? और इसको दूसरी तरह से लिखने का तरीका ये था कि E के बाद क्या मिला है हमें? A. सो यहाँ पे सिंपल माइनस बी ए करके इक्वेट कर दो जीरो से. ठीक है? सम ऑफ पोटेंशियल along the closed loop. I have written sum of potential, right? With proper sign I have written, and I have equated this whole to zero. Why is I have equated it to zero? Because I have written potential change in a closed loop. ठीक है? अगर नहीं भी समझे हो तो कोई दिक्कत नहीं है, आई विल मेक यू अंडरस्टैंड इट मोर. सो अभी तक का टेक अवे हमारा क्या था? दो टेक अवे हमें मिला. पहला ये कि अ, अ, ये सब लोग मार्क कर लो, ठीक है? व्हेन वी ट्रैवल, चलो सभी लोग इस चीज को दिमाग में रखो. डायरेक्शन ऑफ करंट में जाएंगे तो क्या होगा? वी टेक व्हाट साइन? वी टेक नेगेटिव साइन. और बैटरी के केस में व्हेन वी आर मूविंग फ्रॉम दिस टू दिस, इन दिस सेंस वी विल यूज नेगेटिव साइन. एंड व्हेन वी आर मूविंग फ्रॉम नेगेटिव टू पॉजिटिव this way, then we will take positive sign. And why we are taking like this? देखो, साइन का सिंपल गेम है पोटेंशियल से. इफ पोटेंशियल इज इंक्रीजिंग वी विल टेक पॉजिटिव साइन. इफ पोटेंशियल इज डिक्रीजिंग वी विल टेक नेगेटिव साइन. जैसे देखो, करंट फ्लो कर रहा था आर के क्रॉस ऐसे. लेट्स से ए, दिस इज बी. करंट इज फ्लोइंग इन विच डायरेक्शन? फ्रॉम ए टू बी. एंड करंट फ्लोज when there is a positive potential. Current flows when I mean current flows in which direction or in which sense? Current always flows from higher potential to lower potential. So when current is flowing from A to B, it has a simple meaning: VA is greater than VB across the register. ठीक है? So across register, potential at this point is greater than potential at this point, and that is why current is flowing in this sense. So when you are moving in the direction of current, you are going from higher potential region to lower potential. ठीक है? And that is why in the direction of current, we are taking what? We are taking negative sign. Opposite to the direction of current, we will take positive sign. है ना? When opposite, what sign we are going to take? Positive sign. Done it? So whatever these 2 points we have written, these 2 points has to do with we are moving from higher potential to lower potential region or lower potential to higher potential region. So basic keyword क्या है? Keyword ये है कि when you go from high potential to low potential, ठीक है? जब आप ऐसे जाओगे ना, हाई पोटेंशियल टू लो पोटेंशियल अगर आप जा रहे हो तो क्या लिखोगे बताओ? तब लिखोगे नेगेटिव साइन, क्योंकि कम से कम में जा रहे हो, घट रहा है, इसलिए नेगेटिव. एंड व्हेन यू मूव फ्रॉम लो पोटेंशियल टू हाई, यू विल टेक व्हाट? यू विल टेक पॉजिटिव. ठीक है? सो दिस इज द की पॉइंट बेसिकली. ये दोनों तुम्हारा की पॉइंट्स है. दिस इज एक्सप्लेनिंग पॉइंट, दिस एरो एंड दिस एरो, बोथ. ठीक है? बट यू नीड टू प्रैक्टिस केवीएल अलॉट इन ऑर्डर टू गेट एवरीथिंग. ठीक है? तो चलो हम लोग कुछ केवीएल को प्रैक्टिस करेंगे. आई विल गिव यू सर्टेन नंबर ऑफ केवीएल. इजी वाला तो मैंने कर दिया है ना, आई डिड इट ऑलरेडी. सो आई विल गिव यू सम मोर. लेट्स से अगेन अनदर सिंपलेस्ट सर्किट आई एम गिविंग यू. चलो, let's not talk about calculating current. Let's say this is R1, this is R2, this is small r, this is E. ठीक है। अब तुम लोग एक काम करो, तुम लोगों को अभी काम दे रही हूँ, केवीएल लिखो। कौन से लूप में लिखोगे? ए बी सी डी ई एफ एंड वापस ए। सो तुम्हें किस में लिखना है? ए बी सी डी ई एफ ए, इस लूप में लिखना है तुम्हें केवीएल। अब सभी लोग, तुम लोग लिखो, फिर मैं लिखूंगी, तब क्लियर होगा। ठीक है। सो राइट इट नाउ एवरीवन, पेन एंड पेपर निकालो एंड लिखने की कोशिश करो। सो ए पॉइंट से चलना तुम लोग। कहाँ से चलोगे? ए पॉइंट से, क्योंकि ए से स्टार्ट किया है मैंने। ए बी सी डी ई एफ ए, सो वी ए लिखोगे पहले, एंड आफ्टर दैट कीप ऑन एडिंग और सब्सट्रैक्टिंग व्हाट एवर यू रिक्वायर। ठीक है। चलो, आई एम गिविंग यू 1 minute हियर, यू पीपल डू इट, लेट मी नो। सब लोग लिख रहे हैं? आई होप यू पीपल आर राइटिंग इट। सभी को लिखना है, ठीक है, बिकॉज एवरीवन हैज टू लर्न इट। किरण, ओके। Okay, I'm not able to understand what you've written actually. So, ठीक है, ठीक है, सभी लोग 1 मिनट लिखो, लो और लिखो अपनी कॉपीज में। उसके बाद जो मैं लिखूंगी उससे मैच करना, ठीक है, और देखना कहाँ तुमने गलती करी। सो यू डू, देन आई विल डू, एंड देन यू विल चेक। ठीक है किरण, थैंक यू बट फॉर सेंडिंग मी। ठीक है। चलो ठीक है, अब मैं लिखती हूँ। ठीक है। सो चलते हैं। किधर चलना है मुझे? ए बी सी डी ई एफ ए। सो ए से बी पहले मैं चली ऐसे। एक सेकेंड, जस्ट गिव मी सम टाइम। ठीक है। यस किरण, इट सिम्स राइट। लेट्स चेक। ठीक है, थैंक यू। चलो, सबसे पहले हम किधर जाएंगे? ए से बी। व्हेन यू आर ट्रैवलिंग फ्रॉम ए टू बी, देयर इज नो सर्किट एलिमेंट, ओनली कंडक्टिंग वायर, जिसके अक्रॉस पोटेंशियल ड्रॉप नहीं करता है, सो वी डोंट हैव टू राइट इट। Now, when you will come from here to here, also no, nothing got dropped. अब आप देखो किधर जाओगे? B से C की तरफ जाना था, C से D. So let's say current का डायरेक्शन क्या होगा यहाँ पे? This is the positive terminal of the battery. This is negative. There is only one battery in the circuit, so we can say current is coming out from this battery like this. क्योंकि दो है नहीं कि करंट का डायरेक्शन हम डिफाइन करें. There is single battery, right? So from the positive terminal, current will come out like this. I, here is I. Some current will go here. सबसे पहले आप current distribute कर लो, ठीक है? So let's say this is I1 and let's say this is I2. Again here current coming will be I according to KCL, क्योंकि at this junction I1 current is coming from here, I2 current is coming from here. So total current coming is I1 plus I2 and that has to be equal to I. ठीक है? So it is like this. अब ये ऐसे आई जाए, है ना? क्योंकि देखो यहां से आई ही बटा था एट बिफोर सी, आई गॉट डिवाइडेड इनटू टू पार्ट, I1 and I2. So here I is equal to I1 plus I2. And at point D, what will happen? This I1 and I2 will meet together and again form I. So this is I. Current distribution is like this. So for writing KVL, first you distribute the current. I have done it. Now VA के बाद मुझे R1 के across travel करना है, and I am traveling from C to D. That is, I am traveling in the direction of current. So I will write here minus I1 R1. अब चलो D पर आ गई। D के बाद E की तरफ जाना है, कोई करंट एलिमेंट नहीं है जिसपे वोल्टेज ड्रॉप कर सकता है। F तक कुछ नहीं है, यहाँ पे जैसे ही आओगे, स्मॉल रेजिस्टेंस आर यू आर गेटिंग, एंड वी आर मूविंग अलोंग आर इन द डायरेक्शन ऑफ करंट अगेन. सो हियर आई विल गिव नेगेटिव साइन, माइनस आई स्मॉल आर. ठीक है. एंड देन आई विल कम हियर, एंड एट this point I'm getting what? Negative terminal of the battery, and I'm moving from negative terminal to positive terminal. So I will give what sign? I'm moving from lower potential to higher potential, and hence positive sign. And kitna positive? E. Again I have reached at point A, so give your minus sign without thinking anything. VA is equal to 0. So ये तो cancel होगा. Sum of potential, that is minus I1 R1 minus IR plus E equal to 0. So sum of potential change in the closed loop A, B, C, D, E, F, A is equal to what? It is equal to 0. And that is why we are taking any random point A, B or something. From any point you have to just start. You have to move in the closed loop. And then you have to just write the potential changes. You have to write it with proper sign. Then finally you have to equate it with 0. This is how we can write it. ठीक है. अगर we have to write it more, we can do it again. एक काम करो, अब आप लिखो इसमें. ये तो C और D बोला था मैंने. Let's say this is another point, E and F. ठीक है. So अब कौन से लूप में लिखना है? A, B, E. ओके, ईएनएफ तो पहले ही ले चुकी हूँ ना मैं. आई कैन नॉट टेक दिस, राइट? सॉरी, आई कैन नॉट डू दिस because ENF I have already marked. So I need to take different notations. Let's say this is your P and this is your Q. So next loop हमारा क्या है? A, B, P, Q, E, F and A. अब इस लूप में आप लिखो. चलो जल्दी से लिख के बताओ क्या आ रहा है तुम लोगों का. यस, एनीबडी? कर रहे हो ना सभी लोग? आंसर भेजो या नहीं भेजो, सभी को करना है. ठीक है. जितने लोग कर लिए हो वो दे कैन गिव थम्स अप, समथिंग लाइक दैट. चलो मुझे बताओ कितने लोगों ने कर लिया. वेनु हो गया, लक्ष्मी, तेजस्विनी, धनुष, श्री, श्रीहरि, संजू, रंजू. This is the rhyming words. Read me. Yeah, please change your name, please. Priya, Mahesh, Chitra, Kiran, Karthik, Adi, Dhruv. Who is this JNV T? What T stands for? Okay, Venu, thank you. What T stands for? You're from which JNV? One more thumbs up. Okay, Kiran, thank you so much. Thank you. It's beautiful. It's good. ठीक है. बहुत ही बढ़िया. चलो, तो तुम लोग थोड़ा थोड़ा तो सीख गए हो, इतना तो मुझे समझ में आया. सो फ्रॉम ए टू बी व्हेन वी विल मूव, चलो ऐसे यहां से ही मैं मार्क करती हूँ. फ्रॉम ए टू बी, नो करंट एलिमेंट. फ्रॉम पी टू क्यू वी हैव व्हाट? वी हैव रजिस्टर, एंड वी आर मूविंग इन द डायरेक्शन ऑफ करंट. सो वी विल राइट व्हाट? वी विल राइट, अब देखो अब मैं ए बी कुछ नहीं लिखने वाली हूँ. वी विल राइट माइनस आई टू आर टू. एंड व्हेन वी आर मूविंग फ्रॉम ई टू एफ, again we are getting nothing. But when we will move from F to A, then we are getting two circuit element. One is your small resistance R, and across it we are moving in the direction of current. So minus, this is R2, sorry, minus IR, and then there is a battery. We are moving from positive to negative, sorry, negative to positive terminal. So we will give plus E, and this whole change in potential across the closed loop has to be equal to 0. Because after the battery we will again come back to point A. ठीक है. This is this. चलो एक और ट्राई करते हैं. Let's learn it more. So let's say this is another circuit. ठीक है, अब क्या करना है तुम्हें, चलो मैं ना एक काम करती हूँ, करंट तुम्हारे लिए डिस्ट्रीब्यूट कर देती हूँ। लेट से करंट यहाँ से आ रहा है, लेट से आई करंट इज दिस, एंड हियर करंट गोइंग इज I1, एंड हियर करंट गोइंग इज I2। अगर इधर I1 जा रहा है तो इधर I2 जाएगा, and here again I1 and I2 will come, and here it will become I, है ना, because from this side I1 is coming, from this side I2 is coming, I1 and I2 will become equal to what, I, according to KCL, right? So ऐसे हमने डिस्ट्रीब्यूट किया। अब देखो इस डिस्ट्रीब्यूशन से you need to learn one thing, that here there are two batteries, right? So अगर दो बैटरी है then you won't do like कि दोनों ही बैटरी से करंट निकाल लिए, नहीं, only from one battery you will take out current, and that current you will be distributing in the different branches. This is how we distribute, otherwise complicated हो जाएगा ना, तुम यहाँ से भी निकालोगे, यहाँ से भी निकालोगे, फिर I mean, I prefer doing like this. I just take current out of one battery, any of this one, and then distribute current according to KCL, ठीक है? So you can go that way. अब चलो, अब हम लिखते हैं KCL, KVL. So KVL कौन से लूप में लिखूं बताओ? एक काम करो, A B, this is C and A B C A, और एक काम करो, यस A B C A में लिखो, A B C A। रास्ता समझ में आ गया? A B C A, चलो लिखते हैं, मजा आएगा, लिखो और बताओ। ओके, रजिस्टर्स को नहीं दिया मैंने, इसको तुम R1 ले लो, इसको R2 ले लो, R3 ले लो, दिस इज लेट्स से R4, दिस इज R5, दिस इज R6, दिस इज R7। लिख रहे हो सभी लोग? हो जाए तो मुझे यू कैन गिव मी थम्स अप, देन आई विल राइट एंड देन यू विल रीचेक। यस, एनीबॉडी ट्राइंग टू स्पीक? ध्रुव? डन? एनीवन? ओके, ओके किरण, दिस इज, इट सीम्स करेक्ट। तुमने बैटरी को मिस किया आई गेस, और R4 के अक्रॉस तुमने साइन डिफरेंट लिया है। R4 के अक्रॉस यू आर मूविंग ऑपोजिट टू द डायरेक्शन ऑफ करंट, एंड बैटरी को, एक सेकेंड, बैटरी का ईएमएफ मैंने लिखा नहीं, लेट्स से दिस इज E1, दिस इज E2, ठीक है? सो इफ यू आर गोइंग टू राइट इन दिस वे, A B C A, सबसे पहले A से B जब जाओगे, व्हाट आर गोइंग टू गेट, R1, you are moving in the direction of current, so I will write here current in this arm, that is I2, so minus I2 R1, ठीक है? When you will move from B to C, across B to C, We are getting what? We are getting two resistors and we are moving in the direction of current. So negative sign for both. And this is minus I2 R2 minus I3, sorry, I2 R3. Same current going through R2 and R3 with negative sign I will be giving because we are moving in the direction of current. Now from C to A when you are coming, you are going in this direction. That is in direction opposite to the direction of electric current. So R4 के across क्या लिखोगे? Plus what is the current in this branch? I1 R4, and then there is a battery. Across the battery, you are moving from negative to positive terminal. So plus E2, and then you will come here, and here you are again moving opposite to the direction of current. Done it? So you will give here what value? Plus I1 R5, and this whole is equal to 0. ठीक है? Similarly, you can write for any number of branches. Whatever is given, I mean, to the long it is closed loop, you can easily write it. Done it? चलो, let's learn one more concept for today. आज हम खत्म करेंगे इसको. Cells in series we will learn, and then we will learn cells in parallel. So just like you have studied registers in series, है ना? Like this, end to end connected. So if EMF or if cells are connected in series, then how we will deal with it? Let's say this is a cell of EMF E1 and it has an internal resistance R1. Let's say this is a cell of EMF E2, it has internal resistance R2. And similarly here R3, R4, R5. So there are 5 cells, they have internal resistances R1, R2, R3, R4, R5. They are end to end connected, as you can see. Now we want to replace it. We want to replace it with a single cell like this. We need to replace these 4 cells, 5 cells with a single cell. Done it? And this single cell will have internal resistance and also EMF. So what is the value of R here? If you look at R here, so its internal resistance, all internal resistances are in series. Done it? So when cells are connected in series, R equivalent will simply become internal resistance ka R equivalent, R1 plus R2 plus R3 plus R4 plus R5 here. Okay? Now, how you will join EMF? How you will add EMF? That is the question. So, उसके लिए एक simple सा logic है which you need to use. You cannot blindly do E1 plus E2 plus E3 plus E4 plus E5. नहीं. If all the cells has tendency to send current in the same direction, then they will get added. If opposite, they will get subtracted. जैसे यहाँ पे आप E1 को देखो, करंट हमेशा कौन से टर्मिनल से आता है? पॉजिटिव टर्मिनल से. So if you talk about E1, then E1 has tendency to send current in this direction because this is the positive terminal, right? E2 has tendency to send current in this direction. ठीक है? E3 has tendency to send current in this direction, E4 in this direction, E5 in this direction. So all has tendency to send current in the same direction, and that is why here E equivalent will become how much? E1 plus E2 plus E3 plus E4 plus E5. Done it? So first you have to check the tendency. Tendency कहने का मतलब कोई भी बैटरी ऐसे दिया हो, you already know that from positive terminal current comes out and at negative terminal it ends, right? So here if there are so many batteries, for every battery check current driving direction, from which cell current will come out in which direction. If all the directions are same, simply add them up the way we did over here. देखो अब दूसरा एग्जाम्पल मैंने लिया है यहाँ पे, अगर आप ध्यान से देखो तो let's talk about first the R equivalent. So it also has internal resistance like this. So no matter cells are connected in what sense, R equivalent of the cells, I mean, if we are going to replace this whole thing with a single battery of internal resistance R, then if cells are connected in series, R equivalent is always the sum of this thing. We can't subtract it because they are resistances, right? If they're in series, they will get added. So we have added. Now the question is of internal cells. Question is of cell, right? So first cell will try to send current in this direction, second in this direction. अब आप देखो, third has tendency to send current in this direction, fourth in this direction, fifth in this direction, and sixth in this direction. ठीक है, अब आप ध्यान से आइडेंटिफाई करो यहाँ पे आप कैसे ऐड करो, बताओ कैसे ऐड करोगे। अब देखो जो जो सेम डायरेक्शन वाले हैं ना उनको आप ऐड कर लो। सो व्हाट आर द सेल्स इन सेम डायरेक्शन? This is E1, E2, and if I talk about this is E4 and then E5. So I will E equivalent में कैसे लिखूं? Okay, I got some answer. That is very much appreciated. नहीं किरण, तुमने सिर्फ E6 को घटाया, एक और है ना ऑपोजिट में जा रहा है ना। थिंक ऑफ E3, आई मीन टूवर्ड्स राइट वाले को एक साथ ऐड करो। टूवर्ड्स राइट कौन, टूवर्ड्स लेफ्ट कौन कौन करंट सेंड कर रहा है ये बताओ आप। यस किरण, टूवर्ड्स लेफ्ट कौन कौन करंट सेंड कर रहा है? E1 प्लस E2 प्लस E4 प्लस E5, ठीक है। And these are the four cells sending current towards left direction. What are the cells sending current in the right direction? अगर आप right direction की बात करो तो ये E3 है और E6 है। सो यहाँ पे इसको पहले ब्रैकेट में लो, माइनस साइन दो, एंड राइट वाले को यू डू द सब्सट्रैक्शन। सो E3 प्लस E6, ठीक है। सो यहाँ टुवर्ड्स द लेफ्ट 1 2 4 and 5, and towards right that is 3 and 6. So towards left 1 2 4 5, towards right 3 and 6. So this is how you can add cells in series and parallel, sorry in series. So I mean so far we have simply discussed what? Cells in series. Yes. अच्छा तुमने नोटेशन में शायद गलती किया, E1 प्लस E2 प्लस E4 प्लस E5 minus E3 minus E6, right? Yes, that is correct. So this is going to be the thing. This way we can add cells in series if they are connected end to end. Now let's talk about parallel. Parallel combination दिखेगा कैसा? Like this. ठीक है, positive terminal of one battery is connected to positive terminal of other. Negative of one is connected to negative of another, and internal resistance. So definitely combination ऐसा दिखेगा, ठीक है, ऐसे। पैरेलल कॉम्बिनेशन अगर तुम्हारा ऐसा दिखता है, ऐसा, देन यू कैनॉट ऐड द वे आई एम टेलिंग यू, ठीक है। जो फॉर्मूला मैं अभी बताने वाली हूँ, दैट फॉर्मूला यू कैनॉट यूज फॉर सच कॉम्बिनेशंस। यहाँ पे E1 है, ये R1 है, ये E2 है, ये R2 है, क्योंकि इसका पॉजिटिव टर्मिनल इज कनेक्टेड टू नेगेटिव ऑफ इट। वी कैनॉट यूज द फॉर्मूला दैट वी आर गोइंग टू डिस्कस नाउ। So combination has to look like this first. अब देखो इसका R equivalent तो simple है, this R1 and R2 are in parallel, so you will write this. What is E equivalent? So E equivalent will become E1 by R1, E equivalent by R equivalent equal to E1 by R1 plus E2 by R2. If there are more cells in parallel, you will keep on adding more, ठीक है। So like this you can do. इस तरह से आप क्या कर सकते हो, कर सकते हो, clear? So this is the formula. Now if you know R equivalent, you can put the value of R equivalent here, you can calculate E equivalent. Then you may be getting question like कि मैम ऐसे वाले सर्किट का फिर क्या करेंगे? So ऐसे वाले सर्किट को भी आप सॉल्व कर सकते हो with the formula E equivalent by R equivalent। वहां पे क्या हो जाएगा? E1 by R1 minus E2 by R. Sign will change, ठीक है। If positive is connected to positive, all positives are connected together, all negatives are connected together, then formula में plus होगा। If positive and negative are connected, then in the formula you will write negative. But 1 by R equivalent in all the cases are going to be same, that is 1 by R1 plus 1 by R2 plus dot dot, ठीक है। So this is how we combine cells in parallel. Anyone having any doubt in this? If yes, then let me know. Tomorrow ka class we will be starting with questions, ठीक है। Some question we will do on KVL, some questions we will do on cells in series and also on parallel, ठीक है। So you let me know first if anyone has any doubt so far. Today we discussed very important thing, KCL KVL we discussed, and then we discussed cells in series and parallel. All these four concepts are very, very, very important from the point of view of questions that you used to get. ठीक है, तो चलो बताओ. Any doubt, anybody? If yes, you can let me know. Okay, cells in parallel, I need to explain. ठीक है, चलो कोई नहीं, I will do it again. So सबसे पहले मैंने ये बोला कि if cells are in parallel, parallel combination कैसा होगा? It will look something like this. Like this meaning R1 and R2 will be in parallel. You know already how registers look in parallel. ठीक है? So it is like this. And in parallel, if this positive cell has to be connected to this positive. Okay, so for this particular diagram, if I discuss 1 by R equivalent, I mean, we are going to replace this whole battery with a single battery. So this will have EMF E and resistance R. So 1 by R will be equal to what? 1 by R will be equal to, here 1 by R1 plus 1 by R2, because these two internal resistances are in parallel, and in parallel they are getting added to give a single internal resistance, small r. So 1 by small r is equal to 1 by R1 plus 1 by R2. Now is the question, what will be the value of E? So E हम कैसे निकालेंगे? E by small r, this E by small r will be equal to E1 by R1 plus E2 by R2. This is the formula we are going to use. ठीक है? So यहाँ से we can calculate E. E will be equal to how much? E will be equal to R का value into E1 by R1 plus E2 by R2. Where small r is what? Equivalent of R1 and R2 in parallel. ठीक है? Then I said that if combinations doesn't look like this, positive से ना connect होगा. If combination looks like, I mean, एक सेकेंड, जस्ट गिव मी सम टाइम. देखो इस तरह के क्वेश्चन जेईई एडवांस में दिखते हैं जहां पे तुम्हें ऑपोजिट कॉम्बिनेशन हो सकता है. ठीक है, सो सॉरी, दिस साइड जनरली वी यूज नेगेटिव, वी यूज इंटरनल रेजिस्टेंस. सो इफ दे आर कनेक्टेड लाइक दिस, then you can see clearly here positive is connected to negative, negative is connected to positive. They're not aligned on the same side. Positive not on the same side. In this case 1 by r का formula will be same. This is true for both cases, for all cases you will say. ठीक है, but यहाँ पे if you write E equivalent by R equivalent, then you will write E1 by R1 minus E2 by R2. Here you will be giving negative sign. ठीक है, this is what I wanted to say. Anybody, any doubt? किसी को कोई भी तकलीफ है, डाउट है, you can let me know again. I'm here, available. Okay, Kiran. Anybody else? If you have, let me know. Lakshmi, is it clear? Okay, clear है? Okay, thank you. Thank you. चलो ठीक है, फिर कल के क्लास में मिलते हैं with some good number of questions first, and then we will discuss Wheatstone bridge, meter bridge, and ammeter and voltmeter. ठीक है? So first we will do 3 or 4 questions. After that we will move on to the topic, and that is last basically. So more than maximum 2 classes. ठीक है? No doubt. Anybody? Srihari, Priya, Ranju, Mahesh, Chetra, Karthik, Adi, Janvi T, you didn't let me know. Thank you, Kiran. Bye bye. Take care. Priya, thank you. Thank you. Lakshmi. Bye everyone. Then take care of yourself. Let's have break. ठीक है? Everyone relax in the comfort of your hostel or home, wherever. So take care of yourself and keep doing lots of questions. Because next year you have to get into good college. Please keep that in your mind. You are reading for a purpose. Always remember. Remember that purpose. Your dedication will naturally come. ठीक है? So वो सारे लोग अपने दिमाग में रखना, और you have to crack things without taking much tension. So keep on practicing more number of questions. Take care of